Today's talk will be on IVR, Interactive Voice Response Systems. I'm myself Rahul Sasi. I work for Eyesight Partners. I'm a member of Rahul Hackers also. Eyesight Partners is a risk management company. We provide cybercrime mitigation technologies for strategies. We have headquarters in US and we have regional offices in India, China, Europe and South America. Grassroots Hackers is a community of like-minded people. We have members all across the world. We are from security consulting, law enforcement firms. Okay. So today's talk will be we'll be covering these various things. We'll have an introduction on IVRs. We'll go on to a very small banking logic flow. And then we will go on to automating these IVR applications and how to brute force IVR-based authentications. Then we will have SQL injection via phone lines, that is using phones, just your DTMF-based phones. Then we will have a buffer overflow attack via DTMF. So this is not a post exploration talk. This is basically a talk how auditors can understand how to audit applications, audit IVR applications. So this won't let you know how to extract data or how to inject payloads using IVR, but this will be how to test for these vulnerabilities and what sort of vulnerabilities could be found in IVR applications. So IVR, everyone in this room has used an IVR application, knowingly or unknowingly. What is this IVR application? When you make a call to your customer care and when you really want to talk to the support human, this computer-generated voice response back. It will ask you to press a particular number for English. Then it will ask you first, if you want to choose support, you have to choose a particular number on your keypad. So that particular automated computer system, which responds back to you when you make a call to a customer care, that is called an IVR application, interactive voice response. There are actually two ways you interact with these systems. So one is using your DTMF phones. You just have this, you dial into that number, you press a particular number, and choose the options which it guides you to. Then we have the voice support. That is, it could understand. It has speech recognition also. We just have to say support, and the system will understand that you wanted to move to the customer support. You could say banking. Then it got a speech recognition. It will understand that you wanted to take your call to the banking department. So two types of inputs are there: DTMF-based input, that is using your keypad. Then the voice, using your voice. So mainly it's seen phone banking application. We have phone banking, not to confuse with mobile banking. Phone banking is when you make a call to the bank, a computer system responds back. You have to choose the option. You'll have to choose a couple of options like from English, Hindi or whatever the languages. Then you reach a particular place where they ask you to enter your PIN number, your 16-digit PIN debit card number or 12-digit account number on your phone. So this is just a voice call. It's not an Android call. You're not using an Android application or anything. Just a voice call you're making to the system, and the system processes. Then you later enter your ATM PIN number, whatever PIN number they gave you. Now you'll be able to listen to your account balance, your account information, last transaction, all those things. This is just via a phone call. So just to make it more clear, you're missing a lot of parts on this side actually. There's a lot more over there anyway. So see, when you make a call, you make call like you're making a call to your phone banking application, consider IVR call to my phone banking application. So this is me. My call will reach the PBX. That is, I'll explain to you a layer actually. See, these are the many layers. I've actually got 4 different layers. That is a telephone layer. Telephone layer network is like a call. When I talk to my bank, everything that takes it for my call to reach the bank. So it will be your service provider, whatever it is. That is a telephone network. And the TCP/IP network is something which interconnects the internal computer. So if we have an IVR application here, we have an application internally. So this is connected basically using the TCP/IP network. And we will have a VXML telephony server. So this is the main IVR application. This is all the attacks which we'll be talking about. Mainly we'll be concentrating at this particular network. This network got the DTMF detection. That means it will detect DTMF inputs. It will understand voice-based input. So all those things happen here, and then we have the web application. What happens is all the inputs, like I enter my PIN card or ATM number, this input will be converted to numeric digits by the VXML server. This telephony VXML server converts into a numeric digits. So the input is via voice or DTMF. So the conversion takes place here, and the processed input is transferred to the web application. So the authentication takes place in the web application regularly. Now the web application sends a response back that you are authenticated. Now the VXML server will read out the response, and that is what we hear actually. So this is how it happened. I make a call. The call will reach my PBX of the bank. The call will be converted to a voice over IP call. That means if I call 111, now the PBX is just like a routing. The PBX understands that my call was supposed to be a phone banking application, and this call has to be devoted to the phone banking. So if I call 222, that might be for a different application. So this PBX understands that it has to be to that particular application. And so that is how it. I think you understood what IVR is, and everyone understood, right? What IVR is and what. Yes, good. So we will move on. Like we already discussed this. The inputs are via 2 methods. That is, one is using DTMF, the other is speech recognition. That it could recognize speech also. So normally we don't see much of that because our accent doesn't suit with the IVR application. Explain that actually later. So, and one more important thing is it's mainly built in these 2 languages, VXML and CXML, the voice XML language. A voice XML language is when you need both DTMF and what do you call it? CXML input. DTMF and voice input. CXML is only used, call XML is only used when you send it using when you have a DTMF input only, then you don't have a support for voice. So this is the language. It's very similar to XML, but structure is similar to XML, but it's a probably a different language actually. And yeah, fine, cool. So what made me interested was my IVR application, my phone banking application. My bank had a phone banking facility. It allowed me to log into my banking account via a phone call. All I need to do is just dial in a particular number. I'll be greeted with some messages, and after a couple of options, choosing a couple of options on my keypad, it'll ask me to enter my account number. Account number was my account number, like 12-digit account number, or my debit card, 16-digit debit card, followed by 4-digit ATM pin. So what does anything strike for anyone? 4-digit account number. How dangerous it is using a 4-digit account number. See, little bit of theory actually. How many of you have flunked for maths? Flunked for maths in high school? I know most of the hackers have. I'm one. So this is just a very little theory, probability theory. Probability theory is like probability of an event to occur. That is P of A is equal to the total number of events divided by the total number of outcomes. In simple, the probability of me getting a hot wife is equal to the number of hot girls out there divided by the number of chances me as a person getting a hot wife. So that is my chances. So that is P of A. So P of A here is the total number of accounts. That is the total number of customers. Number of customers is equal to the number of account numbers, right? Divided by the number of possible PIN numbers. That is what 4-digit ATM pin has 0001 to 999. That is like 10,000 PIN numbers, right? So the possibility is very less. That is, when you divide by a very huge number of accounts, divide by the 4-digit PIN, the key combination is very less. That means the chances of a particular user, so consider like I start a brute force from account number 1000 to account number 10,000. So the chances of multiple users having the same password, that is 6666 ATM password, will be the same. Got the concept? So the lowest possibility based on our probability theory, let's take 10 accounts. So if you move on, and the best interesting part with the bans were every invalid 3 attempts, your account gets blocked. You ought to be familiar with this. You make 3 invalid attempts, your account gets blocked. But the very interesting part was at night 12 o'clock, your accounts get reactivated. So it's not a time gap. If I start my brute force at 10 o'clock, at 12 o'clock it gets enabled. So what does this strike? What does the hacker this strikes? If I start my brute force program at 10 o'clock and try 1000 accounts for 3 different pins, at 12 o'clock all the accounts will be blocked. So I already made my 3 attempts. But at 12 o'clock again all these accounts will be re-enabled. So I again got another 3 more attempts till 2 o'clock. So if I start my brute force at 10 o'clock and go till 2 o'clock, I got total 6 attempts. You got the thing?
Yeah.
So if you don't want to block the accounts, just do 5 attempts. Just make an attempt, 3 attempts at 10 o'clock to 12 o'clock. Do another 2 attempts after 10 o'clock. After 12 o'clock. So you got total 5 attempts. You could try for 5 different pins for 100 people. So actually, I just made a little automation. You could automate this thing is like, this is a phone call. This is not an Android application. It's a phone call. So you have to automate. You have to guide your phone to make a call, press the particular numbers, send the digits. So this could be done using the 8 commands. We already had a lot talked about 8 commands. Actually, this is something which you guide your modem do something. So 80 and 8 commands. These are the very following commands I used. And we could also use Python for automating it. That's pretty, everyone is happy because Python is something, we can love with Python actually. So the first part, brute forcing IVR applications. And the POC is tested only on my account. No clients or customers were harmed. So it is just a POC, just showing how it's not good. The program will automatically send the PIN numbers to the server. You don't have to dial or you don't have to do anything. Just run the program and it will send the 12-digit account number followed by the password. And it will choose all the options. All the English option and all the options it automatically gets. And now there is no voice, but is it audible in the back? Voice?
Just put the mic in front of you.
Your 16-digit debit card or 12.
This is when we send the pin number actually, this resident account number.
Please enter your 4-digit ATM or debit card PIN or press 1. Authentication is successful. The available balance in your account is 55. 5, 8, 100. Press star to repeat. You know your last 5 transactions.
So you could do a lot more actually. This is just, logging into someone's account, my personal account actually. So if you run this program in the 3D which I explained previously, you could do a lot more worse. So this is just an introduction actually. We haven't even covered half of it. So this is the part which made me interested in looking into these applications. The main reason is it's not the money actually. See, these applications are unaudited. I mean, these applications are always there, and it's connected to the internal database, everything, but it's unaudited. No one cared to audit it, or no one really thought about a security issue over there. And another thing is that,
Are we allowed to ask questions as well?
sure.
So, you automated it using Python, right? And you send the commands after it says, enter your PIN.
Yeah.
So, have you timed these things or you
Actually, yes, you could do it 2 ways. First, you have to do it via time method.
Right.
That is what I have used.
Okay.
Second is you could connect it to a voice detection thing. So if they say enter the PIN, our voice detection should understand that now you should enter the PIN and do it accordingly. But I use it using a time method. That's just a POC. I don't want to harm anyone making a very sophisticated code. So that is actually your method. One is the better way of doing it.
I was just curious how you.
Yeah, this was just timing. So, and the important part is no captchas are there. You just saw the brute force, right? There is no captchas for a voice-based authentication. And no firewalls are there to monitor this line telephone traffic. So in reality, we kind of think that it's very secure, but actually it was not. Moving on actually. So this was the entire thing which made me interested in IVR applications. So these will be the following things we'll be talking today. We'll be having a talk on fingerprinting these applications. I mean, how we could trigger errors in the internal service, because these applications lie in the front. We could access the internal service because it's connected via TCP network. So how we could trigger errors and how we could extract data out of it. Then I'll have a few demonstration of input validation attacks, mainly SQL injection. So and potential buffer overflows. So like I said, it's not a post exploitation. This is like talk on how to trigger this error. So fingerprinting internal servers. So you knew what these applications are, and how could we trigger an error in the internal server, and how will we read out the error? See, you know how to audit a web application. You just send a payload, a random payload. Then the error message will come on the screen. You just have to read out the error message, and this error was there. So this and all those things. But how will you do it on an IVR application? Anyone's got any? How will you read out the errors? How will you read out the errors? If you could trigger an error, how will you read it out? It's very simple. These applications are made to talk to you. I mean, these applications, whatever happens inside, will read it out to you. So if I trigger an error in the internal server, these applications will read out the error to me, right? So we have to automate it. This part will be automated. again, we'll have a little talk about that later. So I'll just have a simple demonstration of a very sample application, how it process DTMF and voice-based input. So this is a sample application showing how the data is processed.
To the Telcon SB1H2F server, to test DTMF, press 1, or to test DTMF, please press any number key on your keypad. Looks like you pressed 5. Welcome to the Telcon SB1H2F server. To test DTMF, press 1, or to test speech recognition, press 2. Please stay
Right.
No mash.
Right.
No.
Are you able to hear that?
Like you said, red, welcome to the Telcon SB1H2F
Or the speaker, put that mic to the speaker.
Test speech recognition, press 2.
For us, you guys are used to it.
To the Telcon SB1H2F server, to test DTMF, press 1, or to test DTMF, please press any number key on your keypad. Looks like you pressed 5. Welcome to the Telcon SB1H2F server. To test DTMF, press 1, or to test speech recognition, press 2. Please stay correct.
Right.
No mash.
Right.
No. Looks like you said red. Welcome to the Telcon SB1H2F server. To test DTMF, press 1, or to test speech recognition, press 2.
This is how it takes input. You just saw how the DTMF input is processed and the voice input is processed. So we'll have this is a vulnerable application actually, where the vulnerability is. I'm not going to explain the entire VXML format, but the important part is the grammar file. This is the grammar file. The grammar file is which defines what sort of input is going to come. If an DTMF input is coming, or you have support for voice input also, and you can't speak in anything. If I say hack me, you won't understand. All the words which are defined in this grammar file, those words only will be understood. So if I say support, it will look for my input, check with the grammar file. If this word is there, if that word is there, use it as an input. So this is the word. So all the input has to be defined in the grammar file. But this application have a problem because the auditor, the people who was developing it, added an extra test value. So if I say banking, it will take me to the procedures of banking department. If I say support, it will take me to the procedures of customer support department. But there is one more option defined, that is test, which is undefined. It's not supposed to do anything. It was just a test value, but it remained there in the main application. So we will show you how that will cause an error actually.
Choose an option.
Banking.
Welcome to SB1 Bank. Have a great day. Choose an option.
Support.
Your call will be redirected to customer support. Choose an option.
Test.
That content is not available at this time. I couldn't find a web page. Error starting voice XML application. Failed dash with code 404. Not found. URL http://127.199.1. That content has an internal error. Error starting voice XML application. XML parse error. S. Occurred in http://199.199/. DOM has session counter equals unknown session that counted equals 1 session that equals E62 B3785821921117.
So So this is how you trigger errors actually. Whatever you do inside, you will read it out to you. So it's a matter of finding these grammar files and finding what input it is, and you will do it. Now we will go on to SQL injection. How much time did I? 10 minutes. So SQL injection. So what all did we learn till now? Whatever we take, the application doesn't understand. If I take quantum of Suresh, it doesn't understand. You have to take quantum of Saul itself. So whatever you find in the grammar file, that has to be the input. So this is something which you have to keep in mind. And we go to SQL injection part. See how hard is it to perform an SQL injection via your phone, and what is the limitation we have? The limitation is because your keypad, your phone keypad, your phone could only send these much payloads. You have a 0 to 9 character, you could send 0 to 9 numerical number. Then you could send star and hash. This is the only characters that you could send to a server. You can't send an extra SQL character, or you can't send anything extra. So this is the limitation we have, and this is the thing which we have to overcome, which we obviously will. So I'm not going to go into SQL injection because I think almost everyone knows what SQL injection is. It's just
Yes, we do.
okay. Okay, so I'll just give a bit of introduction actually. Consider that the vulnerable SQL injection vulnerable login form. Instead of entering the username and password, if I enter some junk values, terminate with the SQL single quote, then I enter or 1 is equal to 1. Or if 1 is equal to 1 is logically correct. 1 is always equal to 1. So I enter an extra command to the SQL query and make the backend think that I entered my username and password was right. So I don't have to enter a username and password. Instead, all I have to do is enter some junk value, single quote, or 1 is equal to 1. So this is the very basic SQL injection actually. And advanced false injection. This concept was dropped by a guy in Exploit. A paper was dropped in Exploit PD two months back. And this concept was used by the Nalcon Hack last web challenge. So many thanks to Amol for conducting, putting this concept into the CTF. And Anil was the one who, guided me to this particular paper. So what it is actually is, previously we entered single quote 1 is equal to 1. But here what you do is, instead of the password, you don't put anything. You don't put any value there. Then you terminate with a single quote. Right. So the password is nothing right now. Then we put is equal to 0. So at this side, the password is nothing. We didn't enter a password. But at this side, we are equating it to 0. So nothing is equal to nothing. So that becomes logically right. Right. So this is false injection. The other is like true injection. That's what the other code. We could call it with whatever name we had. In the same concept, we could do with addition. We could do with multiplication also. I'll tell you the multiplication thing actually. See, I have a user ID. The user ID into 1 into 1 into 1 into 1 is what? The user ID. Any number into 1 is 1, right? And any number into 0 is what? 0. So, what from this payloads, what could you make out? Does anything click for you?
Yes, we can dial it from.
Yes. Star key is there. You got a DKMF star key on your phone. This is a DKMF star key. You have a star key on your phone. DKMF star is there. So that could be used as a payload. So I'll show you a demo application actually. So a demo application which we have built is like, it will ask me to enter my user ID. I'll enter delete. It will say wrong user ID, please try again, because that particular user ID is not there. Then I'll enter elite. Then I'll welcome you with my welcome Rahul, Sasi, or whatever it is. So now how we test it is right. Oh, bad. This alignment thing is very bad. So anyway, so again, it will ask you, IVR will ask you to enter the user ID. You will type your user ID into 1, like star 1, star 1, star 1. That again is like the user ID itself, right? It's been multiplied with 1 and the user ID itself. Now the second time, you use the same user ID. We multiply it with what? 0. Star into 1 into 1 into 0. That becomes this value what? 0. So if the form is SQL injectable, we could do it via the DKMF. We'll show you a very sample demo actually.
Put a mic on.
Please enter your You entered PIN 1337. Please wait while we process your information. No match is found. Please enter. You entered PIN 31,337. Please wait while we process your information. Welcome, Rahul, Sasi. Please enter.
One into one into one.
You entered PIN 31,337. One times. Please wait while we process your information. Welcome, Rahul, Sasi.
Now we'll go for the match to one. Multiply with 0 and 0.
You entered PIN 31,337 times. One times. 0. Please wait while we process your information. No match is found.
Now what? We just did the first escalation via DTMF actually. So this way you could test for SQL injection, you could see if the IVR application is SQL injectable. How to extract data, that is like, when you go deep into SQL injection via DTMF and how to extract data, that is like, actually you could do the same thing actually using voice failover also. A little more thing. See how I find all this is, I didn't test all these applications on a live server. What I did is I joined multiple developer forum, IVR application developer forum. I saw the conversations, I saw the codes which they are sharing to each other. So people, normally you ask it out, people will give you codes. So if I want to send the alphanumeric inputs, consider my user ID is fp1h2s@gmail.com. This is not it's not numeric or it's not alphabet, it's alphanumeric combination, right? How will you send this combination to the server? See, it got character detection, so it could detect it F and 1. But what about at gmail.com? At and dot is a special character. So how will they detect it? So what this programmer does is, these are the sample codes which we got from developer forum. So what they were doing was, if I say at, they'll replace it with a special character at, right? And if I say underscore, fp1 underscore at something.com, they'll replace it with the character underscore. So if I want to give the input fp1h2@gmail.com, what you have to do is, I have to say fb1h2f@gmail.com.
So if I want to type the word...
No, not type.
I'm just asking
Okay.
if I want to type the word underscore, how does that get it? Say my email ID is underscore@gmail.com.
Say underscore. You say underscore and it will get replaced by special character underscore.
That's what I'm saying. My ID is underscore bird.
So you say U and D.
The word itself is underscore.
Okay, the word itself is underscore. Then you might have another error actually. IVR might, you might trigger another error in the IVR. Yes. So
Question is that he is writing underscore@gmail.com. So he has to say U and D. Yeah, something like that.
both ways are there. This application which I'll be demonstrating was taken out from it was from a VXM, UI IVR application developer. Okay, and one more thing I forgot to mention. See, I mentioned about the grammar files, right? There are pre-built grammar files. So this is very complex to build. Taking a alphanumeric inputs is very complex. So there are custom grammar files which are already built. So what you have to do is download this grammar file, attach it to your application, and it will work. And almost every developer does that. There is something free, you do that, right? You just download, you use it in our code. So all the applications which I see, they are downloading it from a particular grammar file. And this was the code which was there in that particular grammar file. So whatever we see, it will be replaced with a special character. So actually, I don't know this part, yeah, it's clear. See, consider if I want to send semicolon. Semicolon would not be there in a grammar file because in a Gmail ID semicolon won't come, so they won't put a semicolon. But if there's a calculator application or something, they have to use percentage, right? URL encoding semicolon. Actually, URL encoding semicolon will give you what? Modulus 27. If I say percentage 27, that value will be converted to a semicolon, right? Same way we could generate more big queries. So this is a 1 is equal to 1 query. That means whatever we entered was right. I mean, the SQL injection wise, logically it will become actually, I mean 1 is equal to 1. 1 is equal to 1 should be. So this should be the payload. I have to say 1 percentage 3 D0. So this particular value will be converted to the actual payload. And you know, actually I'm not going to talk about the post exploitation here. This way, this is a theory actually, this is the way you could do it. You could extract more data, you could dump the passwords and all via the XML. I mean voice XML. Actually we got to talk about Docker also. So this is a demo actually. This is a demo how to take alphanumeric inputs.
Speaker.
B1 H 2 F at gmail.com.
You said fc1h2s@gmail.com.
At was replaced with character at. Dot was replaced with the character dot. So this is the way they process alphanumeric input. I'll show you that vulnerable code also. See, this is a vulnerable code actually. See over here, this is the grammar file. This is the grammar file which they download from the server and attach it to things. So source is equal to the grammar file. You don't have to build your own grammar file. See over here, see dot is replaced with dot. So if I say dot, the word is there, replaced with dot. So if I say
This is the
underscore, actually in this particular it was dash. So I have to say dash, not underscore actually. If I say dash, replace it with dash. So this way you could create alphanumeric, you could create, more custom payloads and you could, and actually that is not our talk right now, but this is the concept. So this is the concept which you could, so we'll move on to crashing remote start off. Right now we understood how to do SQL injection via these systems. Is it possible to crash a remote stack? Or is it possible to execute a code if there is a vulnerable buffer overflow vulnerable application inside in the internal server? Is it possible? Why is it not possible? Because we are sending in numeric input. I mean, we could send alphanumeric input, we saw that right now. We could send in characters also. That means if I say A, it will create a long string, and if the string is sent to a overflow CJ application, let's see there is a overflow CJ application in the backend. This data is sent to that particular server, then we could crash that particular server just using your 10 more minutes. Okay, thank you. We'll just find it. So with these payloads, we'll be able to crash those server. So what are the so actually how we could find these errors is using DTMF Sasi. You have to first using DTMF commands, and then you have to first with voice commands also. And the tool which we'll be releasing not right now will be having these capabilities actually. And actually we'll be got a few more minutes. So this was a vulnerable CJ application. It's got an overflow here. It takes input. It's a CJ application. It takes input from the IVR, process it, and at this particular there is a string copy which is a vulnerable thing. So if we send it with a long string or a long numeric numbers, the thing will crash. One more thing is, what is HTTP error code 500? Internal server error, right? So this you have to keep in mind with the demonstration. So if I could send a long string to this CJ application internal server, I will be able to crash the server. I'll be able to execute codes also. See, and one more thing is shell codes. How will we send a shell code to this server? You can't send shell codes because hexadecimal codes are not enough. You can't slash is not allowed and a lot of limitations are there. That is when we use alphanumeric shell codes. You have alphabet is there, numeric is there, but this is, I'm just explaining the logic, but this is the concept. Alphanumeric shell code you could send using your phone and voice. You would say B3. You could construct payloads. So actually to show you the crash actually. So this is how you, sorry.
Please enter the Please wait while we process your information. Sorry, that content has an internal error. A web server error occurred. Error starting voice XML application failed fetch with code 500. Server error. URL http://192.168.14.7 the_test.cg.
This is how to test actually. We could actually send payloads also. So I explained the limitation of sending slash and all those characters that we could overtake by uppercase numeric shell codes, uppercase actually. And yeah, so that is pretty much it. Queries? No, I haven't tried it on any live applications. That is what I want to request. If you have your bank or your company got an IVR application, we could do it at least for free. I didn't really get hands on giving it on a live application. All the application I tested was on open source applications which are freely available. I haven't really tested it on a real environment till now. Which is because all these applications are there for, majority of the cases found phone banking, which I don't have access to. I have access to my phone banking, but
You are not authorized.
PS ZOC is not going to reveal. It's okay. Thanks.
so anything else?
You showed one demo in the beginning for Python, right?
Yeah, I will.
So, what would be the solution for banks to implement that other than developing firewalls?
I didn't get you. Voice-based capture. And one more thing, see, I really wanted to thank my director, Muslim Kaushal. If there is any good work in my content, that was especially because of his goodwill. His support and motivation was behind this good this presentation. And to my colleagues, Praveen and Swapnil, Praveen has listened to this this talk over and over again, and he is the one who had added all this fun part to it. So I really thank those people more than I thank myself for giving this good presentation. If you consider it good.